Okay, first, 19.1. Before we start, we'll talk about recapping the geometrical properties we learned in O-level mathematics, two parallel lines, straight lines, and you can find all these in the first few pages. Okay, so first part talks about adjacent angles, particularly basic angles, as well as if given two parallel lines, what do you expect? Okay, so the fourth one talks about the perpendicular angle bisectors. So if it's a perpendicular bisector, we know that in this case, it cuts at 90 degrees and bisects the line. So angle bisector bisects the angle into two equal parts. And we'll also talk about properties of triangles. So what are the different properties of triangles, interior, exterior angles, as well as the different types, isosceles and equilateral. So next, this is one of the most important one. Please take note, the congruency test, triple S, SAS, ASA, as well as the RHS test. So finally, the next one, or rather the next one will be on a similar test for angles. Take note that because there are three angles in a triangle, proving two of them the same, the last one will definitely be the same. Okay, yep. So you just need to prove two pairs of corresponding angles. So the next one talks about the special quadrilaterals. Okay, so yep, I'll leave you to read. And finally, the next three will be on symmetrical properties of circles, angle properties of circles. Take note that spinning off from the last one, angles in opposite segment, this one. So this is a cyclic quad. So if given a cyclic quad, and for example, I'm looking at this angle, okay, I call this X. So I know that the one opposite here is 180 degrees minus X, because the angles in the opposite segment. And therefore, the angle that stretches from here, this has to be X. Okay, so we call it exterior angle of a cyclic quad. Okay, so the two angles are the same. And lastly, tangent properties. Please note the last one. This is also important. The tangent from external point. So this will give you two lines that are equal in length. Okay, so we'll first start off with the first example. For geometrical proof, we have to have all the geometrical statements supported by reasons. Okay, so let's look at example 1. Angle BEA and angle CEA. Okay, so if I were to prove, I will need to prove that BEA and CEA are the same. So basically, these are the two angles I need to prove, but I don't know whether they are the same or not. So one of the way is, let's say solve part A, will be to prove that triangle BEA and CEA are similar. So proving are similar, we'll start off with BEA, CEA. Okay, then of course we look at these two lengths, and I know that they are the same, even. So BE equal to CE. Okay, because this is given, so they are the same length. And I also know that AB and AC always refer back to the three letters you wrote there instead of going straight into the diagram. Okay, so AB equal to AC, and this is also given. And since we know that AE is a common length, they are the same length, right? So it's a common, AE is a common length. Therefore, we can prove that triangle BEA is congruent to triangle CEA using triple S congruency test. And since they are the same, therefore angle BEA has to be equal to angle CEA, the reason is they are the corresponding sides, or sorry, corresponding angles. Corresponding angle of congruent triangle, okay, which is the one in the middle here. Okay, so this is for part A. We'll go on to part B. Part B, we need to prove that two triangles BDE and CDE are congruent. Okay, so to prove the congruent, I always aim for the same letter first, okay, or the same length. So DE, DE is a common length. This is the same length, So next, we'll look at what is given. BECE. BECE is given to be the same. And the last one, the tricky one. Okay, so let's look at this. I'll use another color in red. So I have proven previously that these two angles, BA and CA, are the same area. So to find BED, this angle, and CED are the same. So what I will need to prove that. So how do I prove it? So I know that angle BED is actually 180 degrees minus angle BA. So I stop here first. Then I'll go on to the next one. Angle CED is also 180 degrees minus angle CA. So what's the similarity? Because CA, I've proven that it's the same as BA. So I can say this is also 180 degrees minus angle BA. And since they are the same, therefore this is equal to angle BED. Okay, so one length, two length, three length, all given already. Since I have proven that all three corresponding lengths are equal, so I can prove that I have proven that triangle BDE is congruent to triangle CDE using SAS congruency test. Okay, this is for part B. Next, part C. So, given this fact already, I know BDE since triangle BDE and triangle CDE are congruent. Therefore, I know that BD and CD must be equal because they are corresponding length of congruent triangles. Therefore, since they are the same, D has to lie in the middle of BC. So D is the midpoint of BC. Okay, so this is how we prove it, using proof to justify every single statement we do. Okay, so practice 1A and 1B can be found in another video. Okay, I'll move on to practice 2 or example 2. So example 2, similar question. Instead of congruent, now we are proving similarity. So as a rule of thumb, similarity, we'll write out all the letters GHI, JKI. Then okay, we'll look for the same letter first, I or GH, GIH here, JIK here. Oh, I know. Angle GIK is equal to angle JIK. Reason, vertically opposite angles. And this one done. Let's look at the next one, H and K. Oh, it's given here. So angle GHI equal to angle JKI. And this is given. Since two pairs of corresponding angles are equal. Therefore, triangle GHI is similar to triangle JKI using AA similarity test. Okay, that's for part A. Next, we move on to part B. We have proven that triangle GHI is similar to triangle JKI. And so, we know that HI over KI has to be equal to GI over JI. How do we do it? We take HI, you'll find a partner. Then we take JI, we find a partner. Okay, so we know that HI over KI equal to GI over JI because they are corresponding sides of similar triangle are proportional. And since that's the case, we know that HI multiplied by JI will be equal to GI multiplied by KI, and proven this. Okay, so this is for example 2. Practice 2 and 2B can be found in another video. Okay, so let's move on to the last one, which is the midpoint theorem. The midpoint theorem says that if D and E are the midpoint, so D and E are the midpoint of AB and AC. Therefore, if this is the case, if these two are the midpoint, therefore DE and BC has to be parallel. And not only that, AD is half of AB. AE is half of AC. Okay, that's what the midpoint theorem is trying to say, and the converse will be true. Okay, so let's work through one example, example 3. So how do I prove that these three lengths are parallel? So let's look at the first triangle, ABD. This one, ABD. Or I know AG. G is the midpoint of AB. F is the midpoint of AD. So we know that since AG equal to GB and AF equal to FD, this is my proof. Okay, therefore GE is parallel to BD by virtue of midpoint theorem. And let's look at the other triangle, this one here. Same thing, F is the midpoint of AD, E is the midpoint of CD. So CE, since CE is equal to ED, same length, and AF equal to FD, therefore AC is parallel to GE. Reason again, midpoint theorem. And my conclusion is, therefore, AC is parallel to GE, and GE, since it's parallel to BD, so three of them are parallel. Okay, this will be for part A. Next, let's look at part B. Part B, I want to show that GE is half of AC and BD. How do we show it? Okay, so we know that since CE equal to ED and AF equal to FD, therefore we know that FE is half of AC. Okay, from midpoint theorem. Right, midpoint theorem says that FE is half the length of the entire AC over here. And since that also AG equal to AB and AF equal to FD, therefore GF equal to half BD. The GF is halfway of the triangle. So if you want to find GE, it's actually GF plus FE, alright? And this is actually half AC plus half BD. So if factorize out the half, you get AC plus BD. Okay, so this is proven. So that's all for the first 19.1.